in all honesty and reality, you're going to use slope-intercept form more than any of these other forms. I teach them to you because it's part of the course, I guess. And it's not bad to know. It doesn't hurt you to know. It never hurts to know. Well, I should be careful about that. It doesn't hurt to know this. And so it's fine and it can be helpful. Just most of the time you end up putting it in slope-intercept form anyway, or you get the information you need from slope-intercept form. But maybe just so you know what point-slope form is or how to use it, we're going to do this problem. A railway system on a hillside moves passengers at a constant rate to an elevation of 50 meters. The elevations of a train are given for two different locations. That's in this cool picture right here. We're just doing part A, and then we'll worry about part B, I guess. Write an equation in point-slope form, which isn't really all that helpful, but we're going to do it anyway, to represent the elevation of the train in terms of time. How can the equation be used to find the rate of increase in elevation of the train in meters per second? So we're going to first find that first part. Okay, so we're just going to plug in numbers. So right now y and x, those are going to stay as y and x because that just represents time and position. We need our slope though. So we're going to have to find our slope. So let's just plug in one of the points. I'm going to use the 20 and the 42 because I don't want to do the decimal. Y minus 20 equals m, which we don't know, times x, which is x, minus 42 seconds. Okay, that's this point right there. Y minus 20 equals m times x minus 42. We have to find our slope though. So let's use both points for that. Remember that's y2 minus y1 over x2 minus x1. And so we're going to use 20 minus 9, 20 minus 9 over 42 minus 14.5. And that will give me 11 over 27.5, which is 22 over 55, and I just multiplied both by 2, and that, both are divisible by 11, that gives me 2/5. Okay, so with that information I can now write an equation. Y minus 20 equals, so our position, minus 20 meters, equals our slope, which is 2/5 meters per second, times our amount of time, minus 42 seconds. Okay, so that's our equation. That's the first part of this one. Write an equation in point-slope form. We did that, yay, check mark. Kind of confusing. How can the equation be used to find the rate of increase in elevation of the train in meters per second? Well, what is that asking us? What is the rate of increase in elevation of the train in meters per second? Meters per second. Anytime you have something per something, you want to think about your slope. So that tells us that's what our m is. And that we didn't really use point-slope form to figure that out. We used the equation for slope because we needed it. But 2/5, so that means for every 2 meters takes 5 seconds. And we could get that into meters per second. That would be 1 meter every 2.5 seconds. Okay, so that's part A. Part B, at what elevation does the train start initially? Write a linear equation in a form that gives that information as part of the equation. Explain your reasoning. Okay, so we're going to switch now to slope-intercept form because it's more useful. It will tell us where the train starts, right? We know it ends at 50 meters, but we don't know where it starts. And so we're going to kind of move things around to get this into slope-intercept form. Y minus 20 equals, I'm going to go ahead and distribute the 2/5. So 2/5 x minus Sorry. 2/5 x minus 42 times 2 is 84/5. Sounds good. Minus 84/5. I'll simplify that later, maybe. So then I'm going to add 20 to both sides. Add 20 to both sides. Just do a little cutoff here. This is B. This is A. Y then equals 2/5 x minus 84/5 plus 28. I need it in fifths, so I'm going to make it an equivalent fraction. Multiply it by 5. That gives me 100/5, which brings me to y equals 2/5 x plus 100 minus 84 is 16. 16/5. Okay, so lost my x for a second. Okay, so where did this start? Well, when no time has passed, when we haven't moved any meters, so we can plug in a 0 for 2/5, or for x. Y equals 2/5 times 0 plus 16/5. That means that at time equals 0, before it's left, it is at 16/5 of a meter, or 3 1/5 meters, which seems kind of like a strange place to start. I would have probably rounded down and just started at 3 meters, or maybe, yeah, I probably would have just done 3 meters. Anyway, that's how you would do that. Slope-intercept form works better for that because it gives you the intercept. That's our reasoning. Hopefully that was helpful. If you have questions, let me know.